This video is an introduction to the factor label or dimensional analysis form of problem solving. This method is a problem solving method that uses conversion factors. A conversion factor is an equality that is written as a ratio. They are always equal to 1. The ratios are used to cancel out unwanted units while converting to the wanted units. An example of an equality is 1 meter is 100 centimeters. This equality can be written as two different conversion factors. 1 meter over 100 centimeters, 100 centimeters over 1 meter. If you're only looking for one unit, that unit must end up on the top of your problem. So if I use the first conversion factor, I will be looking for meters. If I use the second conversion factors, I will be using centimeters because these are the top units. There are some steps to problem solving. The first is to determine what unit you're looking for and write it down. If you don't know what you're looking for, you'll have a really hard time finding it. Write down the information given in the problem. Find the relationship between the unit given and the unit you're looking for and write it down. And check to see if you have two of each unwanted unit and one of the wanted unit. Do not count the question mark unit. If you have this information, you have enough information to work the problem. Let's see how this applies to the following problem. A small bottle contains 45.5 grams of calcium chloride. What is the mass of calcium chloride in milligrams? What I'm looking for is how many milligrams. What I'm given is 45.5 grams. Grams and milligrams are not the same thing, so I need the relationship between those two units. The relationship is that 1 gram is 1,000 milligrams. If I look at this information, you can see that I have two of the unit grams, 1 milligrams, not counting the question mark milligrams. With this information right here, I have enough information to work this problem. I can get two different conversion factors out of the 1 gram equals 1,000 milligrams. I can either have 1 gram over 1,000 milligrams or 1,000 milligrams over 1 gram. If I use the top one, I will end up with grams. If I use the bottom one, I will end up with milligrams. So I'm going to use the bottom conversion factor in my problem. To actually work the problem, start with the number given in the problem, which is 45.5 grams. Next comes the correct conversion factor. Because I want milligrams at the top, I put in the 1,000 milligrams over 1 grams. And if you notice, the grams over grams will cancel. It doesn't matter that they are on the diagonal from each other. As long as one unit is on top of the same unit, it will automatically cancel. Conversion factors are kept together in a problem. You also must use sig figs to solve your problems. In this, you always use the number given in the problem for your sig figs, never the information in the conversion factor. Conversion factors are said to have an infinite number of sig figs. So I have 3 sig figs in my original number, I have 3 sig figs in my answer, and my answer is 45,500 milligrams. Let's look at another example. I'm going to convert 0.49 kilograms to grams. I'm looking for grams. I have kilograms. My relationship is 1 kilogram is 1,000 grams. I can again write two different conversion factors, 1 kilogram over 1,000 grams or 1,000 grams over 1 kilogram. Because I'm looking for grams, I want the conversion factor on the right because that puts the grams at the top of my problem. I'm going to start with the number given to write my problem. I'm going to pick a conversion factor such that the original unit and its matching unit are on a diagonal, therefore they're on top of each other and will cancel out, and what I'll be left with is the unit I'm looking for, which in this case is grams, at the top. I'm going to multiply the numbers at the top of the problem. In this problem, I don't have meters. I have centimeters, I have millimeters, but I don't have just meters. Anytime that you have a unit abbreviation with with no prefix in the front of it, it's a sign that you're going to have two different equalities to deal with and two different conversion factors in your problem. I'm looking for millimeters. I've given 5.2 centimeters. What I know is 1,000 millimeters is a meter and 100 centimeters is a meter. I'm going to start out with the 5.2 centimeters. I'm going to make the bottom equality into a conversion factor with the centimeters on the bottom, because that will cancel the original centimeters given in the problem, and put the meters at the top. Then, because I'm not looking for meters, I need to put another conversion factor in. I'm going to use the top equality to make a conversion factor, and I'm going to put the millimeters at the top and the meter at the bottom. If I do this, the meters will cancel, and I will be left with millimeters at the top. To work this problem on your calculator, there are two different ways of working it. Multiply the 5.2 by the 1,000 and then divide by the 100. You divide by that 100 at the bottom because it is actually underneath that horizontal line, which is a division bar. Hit the equal, you get 52 millimeters. The other way of working it is by conversion factor to conversion factor. This way I would have 5.2. The first conversion factor says divide by 100 because that 100 is under that division bar. So I'd take 5.2, divide it by 100, and then multiply it by the 1,000 because that is on the top. Anything on the top is a multiplication problem. Anything on the bottom is a division problem. I'll get the same answer either way. Write down any questions that you may have and bring them to class tomorrow. I'll answer them for you, and we will work some problems for more practice.